Good morning. Today we're going to be learning about cosine functions and how College Board presents them and how College Board wants you to be able to interpret them. So we'll be looking at the form of the equations and what the variables represent, and then we're going to see how these equations themselves relate to graphs like this, graphs of cosine functions. So we're going to be going from the function, from the equation to the graph, and from the graph to the equation. Now, some of you may have had this in your math classes before, so you can probably watch this fast, but that's fine. Now, the hardest part of this is in manipulating the equations that they give you and putting them into a useful form. So that's going to be about in the midpoint of this video, and that's the trickiest part of it. Okay, so let's see. Let's start off with the equations themselves. Okay, well, now what I'm going to show you is we're going to start off with the form of the equation that is in the book, and that is on page 445 of your book. And I'm using the form that the book uses first because you can follow along with it if you need to dig through it. Now, as we see as we move forward, the form that AP uses is really very, very similar. It looks different, but when you understand what they're doing, it's actually pretty much the same thing. So don't be too dismayed by the fact that College Board uses a different form than the textbook. All right, so what does this look like? These functions, when we say function, we're talking about function in terms of a mathematical equation. It's describing a graph where we're determining x at any point, and these take the form of a cosine, and it's the cosine of a quantity. There's going to be 2 pi divided by t times little t. So we have a big T in the denominator, little t in the numerator, and we're taking the cosine of this whole thing here. What do these represent? Okay, x is the displacement on the x-axis. Hey, x is the position on the x-axis. Now, we're used to using the x-axis as the horizontal one, but the book and AP, for some reason, makes x the vertical axis. I'll show you this when I give you an example in just a moment, but they say x, but they really mean the y-axis, the up and down axis. And this is a function of vertical position as time passes. So small t is the particular point in time that you're interested in. So point in time of interest. So what this means is you can use this equation to figure out where in this up and down cycle the object is at any given point in time. Okay, so what is A? A is the amplitude, of the oscillation, which means how high or how low the thing is displaced. Cosine is just cosine. 2 pi is just 2 pi. T is the period. We have seen this before. Which is the time in seconds to complete one oscillation. Complete one oscillation. So to go from one extreme to the other extreme and back to the beginning point again. That is the period t. And small t is what it is. Okay, so now why this 2 pi thing? 2 pi has popped up before when we talked about radians. And it turns out that this equation assumes that you're doing everything in radians. Because remember, there's 2 pi radians per circle per 360 degrees. If you start here and go all the way around, that's 2 pi radians. And because cosine functions and sine functions are cyclical in nature and can be boiled down to circles, it pops up here as well. So the 2 pi means that we are dealing with something in radians here. This is 2 pi radians per cycle. It really doesn't come into play too much because the only time this would really pop up its head is if you wanted to actually solve this equation and start plugging in values, you'd have to make sure that your calculator was set for radians so that for a given time you'd find the correct position on the x-axis. But we don't do that very much. Basically what we're doing is we're using these variables to figure out what the amplitude of the oscillation is and the period of the oscillation, and then plug those values into other equations that we already have. Or alternatively, we're looking at a graph which has already been created, and we're pulling information off that to plug into these spaces in the equation. So the fact that it's all in radians really isn't that big a deal. It just doesn't pop up. Now, if you did this in your math class, they would probably have you actually creating the graphs, and then it might make more difference. But for us, we're interested in amplitude and period, and that's about it. And the fact that it's in radians is incidental. Okay, so that's what the variables mean. So now let's see how this looks on an actual graph. Put this in here. Okay, cosine functions again. So now we have a cosine function. We know this is a cosine function because it begins at max amplitude. Remember, the cosine of 0 degrees is 1. So if you start with 0, take the cosine of it, it is 1, which means that our graph will begin at the extreme. It's 1 times whatever the amplitude is. Now, if it was a sine function, the sine of 0 is 0. So a sine function would look exactly the same, except that it would begin at the origin. Generally speaking, AP will only give you cosine functions. They always start at the extreme, and they are more convenient to work with. So that's what we are. That's what we have. Okay, so this is the equation that the book uses. A cosine 2 pi t. So we're going to take this graph and see what it looks like when we put it into the form of this equation. So we're going to start off with x equals, okay, so A is the amplitude. You can look at your gouge for that. The amplitude in this case is 3, so this is going to be a 3. It's a cosine function, so there's that. Now, what's going to be inside? Well, 2 pi divided by the period. So what is the period in this case? Well, this is 1 second to here, quarter second, half a second, 3/4 second, 1 second. So the period, this is 1 full cycle. From here to here, this is 1 full cycle. So our period is a half a second. So we're going to divide this by 1/2. And then we're going to put in the little t, which is the moment in time that we are interested in. Now this is a little bit convoluted, so we can simplify it a little bit. If we're dividing by a half, that is the same as multiplying by 2. So this is equal to 3 cosine 2 pi times 2 times little t. Right? So we took the 1/2, we divided by a half, and it's easier to simplify it to multiplying by 2. Now, this is a good time to pause this process just for a moment and look at how AP presents this same equation. This is not a non sequitur. These actually go together very well. So here's how AP sets it up. They do a cosine, and they say 2 pi f times t. F is the frequency. This is the frequency in hertz, which, as you probably recall, is cycles per second. Okay? Now, what does this mean? As you recall, the period is the inverse of the frequency, and likewise, the frequency is the inverse of the period. So what did we do here? We took the period, t, and we took the inverse of it because it made the equation neater. So this 2 right here is the inverse of the period, which means that this is the frequency. Okay? So if we were using the AP form of this, we would look at this graph and say, hey, well, what is the frequency of this oscillation? And we'd say, well, in 1 second, there are 1 2 full cycles. The frequency is 2 cycles per second. 2 cycles per second, and we would put in the 2 for our f, and we would get to this point right out of the gate. Okay, so this is the book form. This is the AP form. As we'll see moving forward, they are both useful. We can simplify this further. This comes to 3 cosine. We can combine those two terms. 2 pi times 2. So we get 4 pi times t. And that's it. That is the equation which describes this graph. Okay, now that's all very nice, and it's easy to see when we go that direction. But what if College Board gives you this function and says, hey, tell me the amplitude, tell me the period, tell me the frequency? How do you go from this back to something that is more useful where we can actually identify the frequency or the period? This is the period. Okay, so basically what you have to do is undo what we did to get here. I'll simplify it for you. What we're interested in is this 4 pi function. We need to expand this so that it is 2 pi times something, or 2 pi divided by something. So how do we do that? We start with a 4 pi, because that's the term we're interested in. We multiply it by 2 over 2, because you can multiply anything by 1 and it's still itself, and 2 divided by 2 is 1. Now, this goes to 2 pi, that's the 2 pi, times 4 over 2. That means that 4 over 2 is 2, so that equals 2 pi times 2, and there you have your frequency. That's the frequency. Make that neat. And if you want the period instead, you take the inverse of that. F equals, well, t equals 1 over f, which equals 1 over 2 equals t. All right, so to summarize, if they give you an equation where there is not a nice neat 2 pi in there, you take the that piece of the function and you multiply it by 2 over 2. That gives you 2 pi times what's left over, and what's left over can be then interpreted into the frequency or the period, depending on whatever you need.